Let's look at some basic heatsink properties that affect the heatsink's thermal resistance. First, we can choose between air and liquid cooling. The input fields below are filled with default values. Relative values are often used, but of course, it is possible to specify exact dimensions or values by selecting the customized option from the menu. For example, let's make a 300 by 215 millimeter heatsink. The R theta now changes according to the new specification. Previously, it was 35 Kelvin per kilowatt with the default values. The airflow is specified as a speed in meters per second. The heatsink width and length of the fins define a cross-section for the airflow. This cross-section then defines the air volume per time, which must be provided by the fans. Selecting liquid cooling is a simpler option. The heat transfer is modeled for simple water channels valid for temperatures above 40 degrees Celsius and a water glycol mixture of 50-50. The modules on the heatsink are more or less thermally independent. Each module has a specific number of water channels based on its dimensions. The distance between the modules influences the thermal coupling factor. However, at more than 25 to 30 millimeters, the heat sources are thermally decoupled. A wider distance does not improve the cooling any further. Because each power module is more or less considered thermally independent, no limitations exist in the mechanical dimensions for the simulation model.